Let's now learn about QR factorization. QR factorization, or QR decomposition, is a mathematical technique in linear algebra where a matrix A is decomposed into the product of two matrices. Matrix A is the product of matrix Q and matrix R. Matrix Q is a matrix with orthonormal columns, and matrix R is an upper triangular matrix with positive entries on its diagonal. QR factorization is primarily used in solving linear systems, solving eigenvalue problems, least squares problems, and then also in computational linear algebra problems. As I mentioned above, matrix Q is a matrix whose columns are orthonormal vectors. Since the columns of matrix Q are orthonormal vectors, there's a property that states that Q transpose times Q is equal to Q times Q transpose, and that's equal to the identity. Because Q transpose times Q and Q times Q transpose is equal to the identity, that tells us that Q transpose is the same as Q inverse, and that's going to come in really handy. I've written down an example of a matrix Q that contains three vectors, Q1, Q2, and Q3. And because the vectors Q are orthonormal, all their dot products are equal to 0, and their magnitudes are equal to 1. Let's now talk about how to find the upper triangular matrix R. We're going to set matrix A, that's the matrix that we're going to be given, equal to Q times R. And then to find R, what we're going to do is we're going to multiply both sides of this equation by Q transpose. Since Q transpose is equal to Q inverse, this just means that we can find R, and it's going to be equal to Q transpose times A, because this is going to become our identity matrix. To make this process easier, I've written down 2 steps that you can follow to find the QR factorization of a given matrix A. I'm just going to assume that our given matrix A has 3 vectors in it, and I'm going to call these vectors x1, x2, and x3. The first step you're going to have to do is you're going to use the Gram-Schmidt algorithm to transform these 3 vectors, x1, x2, and x3, into orthogonal vectors that we're going to call v1, v2, and v3, and transform them into orthonormal vectors, which we're going to call Q1, Q2, and Q3, and then create matrix Q that's equal to these 3 orthonormal vectors. The second step is you're going to compute Q transpose times A, and then create matrix R, which is just Q transpose times A.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.